Hello everyone, myself Shinde working as assistant professor at Department of Physics, KTHM College, Nasik. Today we are going to discuss MSc second year, semester third, paper number 4, that is the course of energy studies first. In today's lecture, I have discussed or start the second chapter, solar radiation and its measurement. In today's lecture, I have also discussed the importance of solar energy and the nature of solar radiation. First, we have discussed the syllabus of second module or second chapter, solar radiation and its measurements. First point is importance of solar energy. Nature of solar radiation. Sun as a fusion reactor. Spectral distribution of terrestrial and extraterrestrial radiation. Estimate of extraterrestrial solar radiation. Radiation on horizontal and tidal surfaces. Another one point is nature of solar radiation in beam, diffusion, global radiation and their measurement by pyranometer, pyrhelimeter and sunshine recorder. Now we have discussed the first one point is the importance of solar energy. First topic is or first sub point is solar energy usage. One of the most troubling issues of today's is the rising cost of energy. Energy costs are on the rise as Earth's resources are being depleting little by little. Technology has provided new resources from natural entities such as solar energy. Solar energy uses this very high or very large in ratio of the energy. That's why the new resources are developed or technology is researched by and produced. The new resources is a solar energy. Solar energy helps the environment. Solar energy is one of those renewable resources that is a great for the environment. When you work with a renewable energy company, you are getting your power from renewable resources. Solar energy being one of them, this type of energy does not produce greenhouse gas and it does not pollute water or air. Means the solar energy is helps or helpful from environment. That's why this energy does not produce greenhouse gases or any pollution, means the water pollution or air pollution. That's why the solar energy is very important or helpful from the environment. The electricity prices independence. When you work with a regular utility company, your prices are likely on the rise at all times. But when you are on the grid with a renewable energy company, you have much steadier rates. Means the work with a regular utility company. That's why these companies the energy is more than or electricity is more than. That's why the any price are included or any price are that's like on price. But the solar grid are fitting that or assemble that these company are renewable energy companies that have a much lower or fixed prices are fixed price rate. That's why the solar energy is very important. So this is the importance of solar energy. Improve the grid security. There are many advantages to use solar energy through a renewable energy company in both big and small bits. Consumers have questions, but as they do research, they see the benefits. That's how the improved grid security. Means grid security are improved that these renewable energy companies and very strong security. And new research are developed that the improvement of grid. That's why this is the importance of solar energy. Now, discuss with nature of solar radiation. Following are a type of solar radiation based on their nature. Means the following types are the solar radiation based on their nature. They have three types. Now, discuss one first one with a diffuse radiation. Diffuse radiation is defined the solar radiation scattered by aerosols and dust molecules. Does not have a unique direction. This diffuse radiation, it does not have a unique direction. Second one, direct radiation. That proportion of the indirect solar radiation which comes directly from the solar disk without reflection from other subject is called direct radiation. Means these rays are incident and in other any object, not a reflection or not a scattered or not a reflect. They are pass or direct incident on substrate. That radiation is known as direct radiation. And also first point, the solar radiation are incident on substrate or subject or dust molecules. They have scattered, not a unique direction. This radiation is known as diffuse radiation, and the radiation are incident on substrate. They have no reflect any object or other object. That radiation is known as direct radiation. And third one type is extra-terrestrial radiation. Solar radiation incident outside the Earth's atmosphere is called extra-terrestrial radiation. Means this radiation incident outside the Earth's atmosphere, this radiation is known as extraterrestrial radiations. Now, the nature of solar radiation, this point is over. Now, discuss with spectral distribution of solar radiation. In spectral distribution, in this point, we have discussed the spectral distribution, but they have two types of spectral distribution. The spectral distribution of terrestrial solar radiation and spectral distribution of extraterrestrial solar radiation. These two types, now the first one introduce that the spectral distribution solar radiation. The sun's emission extra indicate that the sun is a black body radiator at a temperature of 5762 Kelvin. The intensity is maximum in a green portion of the visible spectrum, that is at 0.48 micrometer. This is intensity green portion, and the sun's emission spectra indicate that the sun is a black body radiation and have a temperature of 5762 Kelvin. And the visible spectrum, that's intensity is 0.48 micron, or this green portion of a visible spectrum is intensity that the 0.48 micrometer. The sun's extraterrestrial spectra irradiance from 0.12 to 100 meter, the range in which all the sun radiant energy is contained for all practical purposes. These extraterrestrial spectra irradiance from 0.12 to 100 meter, the range in which all the sun radiant energy in contained for all practical purposes. The energy contained in the ultraviolet region 9.20 meter and in the visible region 0.40 micrometer to 0.70 micrometer are respectively about 8.736 and 38.15% of the total energy released by the sun, and the remaining 3.12% is contained in the infrared region. That's why the infrared region is 0.70 micrometer. This is the region for energy content. The ultraviolet region is the 9.20 meter and a visible region is 0.40 micrometer to 0.70 micrometer. That's why the respectively percentage of total energy released by a sun is 8.736 and 38.15%, and remaining 3.12% it contributes that infrared reach 0.70 micrometer. The figure shows the spectral distribution of the extraterrestrial radiation available at the mean Sun-Earth distance for 0-year mile and 1353 watt per meter as the solar constant. That's why the figure showing that next slide, the spectral distribution of extraterrestrial radiation available with Sun's Earth distance is 0-year mile and 1353 watt per meter as a solar constant. This is the distance of Sun to Earth. However, due to the fact that the Earth revolves around the Sun not in a circular orbit but follows an elliptic path with the Sun are one of the foci. There is a variation in the extraterrestrial radiation Sun that the Earth is revolving around the Sun. This is not a circular orbit, but they have elliptical path. Earth's around the Sun. There is a variation in extraterrestrial radiation. In figure showing that spectral beam radiation and wavelength micrometer. In here showing that the graphical representation. That's why this is the graph of increases and particular point they have also decreasing path, but the decreasing is very slowly and constant path here. The 0.48, that's the solar spectral distribution here. The visible region. They have the visible region watt per meter square. That is the spectral beam radiation is the watt per meter square. That is the solar radiation constant. Okay, value. Spectral distribution of solar radiation intensity is the graphical representation here. Now, discuss with the spectral distribution of terrestrial radiation. From the point of view of a utilization of solar energy, we are more interested in the energy received at the Earth's surface than in the extraterrestrial energy. Solar radiation received at the surface of Earth is entirely different due to the various reasons. Before studying, this is the important to know the following terms. This is a point of view of utilization of solar energy. More interested in solar received from Earth's surface than in the extraterrestrial energy. This solar energy received from surface of the earth is entirely different due to the various reasons. This study we have also before the one term are study importance. This term is beam and diffuse solar radiation. These terms are very important for the spectral distribution of terrestrial solar radiation that have the importance term that is the beam and diffuse solar radiation. That proportion of the incident solar radiation which comes directly from the apparent solar disk without reflection from other subject is called direct radiation. Means the solar radiation is passed or come from directly from the apparent solar disk without reflection from other subject. This radiation is incident on a portion or on a solar disk. That radiation is known as direct radiation. Their radiations are received from the sun without change of direction. Diffuse radiation is that solar radiation received from the sun alter its direction has been changed by reflection and scattering by the atmosphere. Diffuse radiation means these radiations are changed by the direction of reflection and scattering by the atmosphere. That's the radiation radiation is known as diffuse radiation. Diffuse radiation is defined solar radiation scattered by aerosol and dust molecules. It does not have a unique direction. This radiation is known as diffuse radiation. Means solar radiation on incident on substrate or solar disk, they have dust molecules. These molecules they have scattered by the solar radiation. This solar radiation is known as diffuse radiation and it does not have unique direction. Total solar radiation or global solar radiation is all radiation incident on a surface including scattered, reflect and direct. Means the total solar radiation or global solar radiation is equal to the radiation is incident on a surface that include the scattered radiation plus reflect radiation plus direct radiation is equal to total solar radiation or global solar radiation. Total does not include radiation that has been absorbed by matter and then re-emit because most of this radiation is at a long wavelength 3 micrometer. But the total radiation does not include the all radiation that have absorbed by the matter. Some radiation they have absorbed by the matter and then re-emits because this radiation is a long wavelength 3 micrometer. Diffuse solar radiation is the total radiation minus the direct radiation or beam radiation. This solar radiation is the total radiation, the direct radiation or beam radiation. The extraterrestrial solar radiation is entirely direct or beam radiation. They have the terrestrial radiation and the extraterrestrial solar radiation is entirely direct or beam radiation. Here in this figure showing that terrestrial radiation, surface of earth, the extraterrestrial radiation is a diffuse scattering and diffuse radiation. The atmospheric absorption warming of air, showing here warming of air by the atmospheric absorption, the direct solar radiation. These are the extraterrestrial radiation. The diffuse scattering, they have reflected back into space the radiation. These radiation are reflect back to space, the diffuse radiation, and the reflected back by surface. Some radiation is reflected by the atmosphere in back space. Okay, this is the figure showing that the terrestrial solar radiation. As that radiation passes through the Earth's atmosphere, it undergoes a complex interaction with the various components of the atmosphere, or major factors of scattering from molecules or dust particles, absorption by the atmosphere and reflection. That's how scattering by the major factors. A significant fraction of radiation which reaches the surface of the Earth is reflected and encounters a similar set of interaction. The remainder is absorbed by the surface of Earth. The significance that of solar radiation which reaches the surface of Earth is reflected and encounters set of interaction. The remainder is absorbed by the surface of the Earth. That's the significant fraction of the radiation. Now, discuss with another one point is a spectral distribution of extraterrestrial radiation. First, radiation increases sharply with the wavelength. The maximum 0.48 micrometer and decrease asymptotically to 0. The 99% solar radiation is obtained up to wavelength 4 micrometers. 99% solar radiation is above or obtained to wavelength of 4 micrometers. The intensity curve shows solar flux is a maximum in region of visible radiation. That is the 0.38 micrometer to 0.78 micrometer. The intensity curve for solar flux is maximum, the region of solar radiation. The curve is useful to calculate the solar flow entire by any specified range of wavelength. The curve is useful to calculate the solar flow entire by any specified range of wavelength. That's the calculated by the curve. A curve is useful to calculate solar flux. The solar radiation is absorbed and scattered as it passes through the atmosphere. The solar radiation is absorbed and scattered that it passes through the atmosphere. The absorption is due to presence of ozone, water vapors, and a lesser extent to other gases like CO2, NO2, CO, O2, etc. The ozone absorbs in ultraviolet band. Then it absorbs short radiation below 0.29 micrometer. The water vapors absorb in infrared bands, and the scattering is due to all gaseous molecules and matter in atmosphere. That's how the ozone absorb is a ultraviolet band, means they have short radiation below or absorb short radiation below the 0.29 micrometer, and the water vapors absorb by infrared band, and the scattering is due to all gaseous molecules and matter in atmosphere or dust molecules in atmosphere. The scattering radiation reflected back at some space to reach the Earth's surface as a diffuse radiation. The scattering radiation is reflected back to the atmosphere and reach the Earth's surfaces as a diffuse radiation. The radiation on Earth's surface is partly beam radiation and partly diffuse radiation. Thus, the solar radiation received on Earth's surface is an attenuated form. The solar radiation received on Earth's surface without changing direction is called beam or direct radiation. Without change the direction of the solar radiation, this radiation is called beam or direct radiation. The radiation received on Earth's surface from all parts sky hemisphere is called diffuse radiation. It means partly sky and atmosphere, Earth's surface by receiving the radiation. These radiation called diffuse radiation. The sum of beam and diffuse radiation is called as total or global radiations. The intensity of diffuse radiation coming from various directions in sky is not uniform and is said to be isotropic in nature. These diffuse radiation coming from various directions in sky and they have not uniform, that's the isotropic nature. That's the radiation is isotropic in nature. The figure showing that the spectral distribution of extraterrestrial solar radiation. In figure showing that the light, visible light and infrared vision. In visible light they have 0.38 micrometer to 0.78 micrometer vision. In this here, the spectral radiation watt per meter square and the wavelength micrometer, the spectral distribution extraterrestrial radiation figure showing that. In this lecture, we have to cover the importance of solar energy and the spectral distribution of the solar cell. This is the introduce that and the some two topics of spectral distribution is also studied the terrestrial solar radiation of a spectral distribution and the spectral distribution of extraterrestrial solar radiation. They have also studied. Thank you.